This video is a video to help you summarize the circular motion lab that we worked on last week. If you remember, the goal is to describe and predict circular motion. If we're going to do that, we have to better understand the force that causes circular motion. If you remember from our observations, you must always push the bowling ball toward the center of the circle to cause circular motion. We can call that force a centripetal force. I prefer to call it a central net force. The goal of the lab is to figure out what variables affect that force. You can do 3 testable questions. How does mass affect how big the force is that needs to push toward the center? How does speed affect the central net force? That whatever force it is pulling toward the center, it might be tension, might be a push, might be gravity if the moon is going around. And how does the radius of how big that circle is affect how big that force needs to be? A few things. As the mass goes up, the force will go up. If you're doing a bigger and bigger thing, it's going to be harder and harder. The mass will be on top of an equation. As the speed goes up, the force goes up. The speed will be on top of the equation. As the radius goes up, if you're in a car and you're making a turn in a circle, if you make a bigger and bigger turn, you have to turn less. So it's actually easier to make that turn. If you do a bigger and bigger turn, the force is less. Radius should be on bottom of the circle. This is not what the full equation looks like. We have to collect more data and finalize that equation. When you do your experiment on the app online, you might make 3 graphs. And I think many of you have done this already, but if you do the force versus mass graph, you should likely get a straight line. Y is equal to slope times x, or force is equal to something times mass. You'd likely get a parabola like this one for force versus velocity. Y is equal to something times x squared, or in other words, force is equal to something times velocity squared times the speed squared. And finally, the radius, as the radius goes up, the force goes down. Force is equal to something over radius. What we need to do is we need to sort of combine all 3 of these equations. They only tell part of the story. The part that this tells is about mass, but it doesn't tell us about velocity and radius. The part that this tells us is about velocity or speed, but it doesn't tell us about mass and radius. The part that this tells us is about radius, but it doesn't tell us about mass and velocity. If you combine these, you just get mass times velocity squared all over radius. If we return to that equation on the front page, mass times speed squared, mass times velocity squared. Mass times speed squared over radius. We might need to change that so that it's speed squared, or you might say velocity squared. There's the full equation for the force that causes circular motion. This answers all 3 testable questions by saying as mass goes up, force central net goes up. As speed goes up, force central net goes up at a quadratic rate in a particular way. And as the radius goes up, force central net goes down. This equation answers all testable questions. Getting this equation is the goal of our lab. You need to cite evidence from those graphs to explain why that equation is the case.